for specialized segments today. Mention I did about specialized segments. Oh yes, not a live show today, but a chance for you all to take your pencil, get your paper, sit back, relax, do some math with me. And you know, it's also summer school time, so put it all together. Let's have a good time today. Enjoy the show, and let's see what kind of topic we're going to look at. Looks like fractions and percents. What more fun could we have working in summer school Mathline? Absolutely a lot of fun we can have. Let's take a look at fractions and percents. Where are we going to go with it? Are we going to relate them? Are we going to work some problems with them? You decide. Let's see our first problem, see what we've got going on here. It says we're going to change 3/4 and 3/8 to a percent. Now this is just two separate problems, all right? We're going to look at two separate situations and a couple of ways we can work with this. Now, remember, you can write a fraction as a decimal, and you can also take that decimal and turn it into a percent. That, to me, is a great way of doing this, all right? Easy way. Another easy way is let's set it up with a proportion and find our part out of 100, all right, that we would have. So let's see where we're going to go with all these good things. One step at a time. That's the way I like it, one step at a time. So you get your pencil, paper, everybody ready out there? Oh yeah, I see, I can tell you are, I can tell you are. So let's check into 3/4, see where we're going to go with it, all right? So remember, 3/4, when we're talking about a fraction, that's division. So it's saying 3 divided by 4. What we want to do is take that 4, you got me? And we're going to divide it into 3. Now, where do we go from there? Because obviously you say, Ernie, you can't divide 4 into 3. You're right. So put that decimal, put that 0 in there. Should be a quick review on these. I hope most of y'all are saying, oh yeah, I remember. Oh yeah, I knew that to begin with. Now, what happens here is we're going to say, how many times will 4 go into 30? And it goes, folks, about 7 times. 7 times. Remember, we multiply it 7 times 4 there. We get 28. Looks like we're going to bring down a 2. And I need one more 0. Maybe more, but we'll see. 4 goes into 20. Bring it down. We're good. That goes in there 5 times. 5 times 4 gives us about that, 20. Nothing left over. And, got to put a decimal in there, don't we? Right there we are. Now remember what I said. Oh yeah, I said a lot of things, don't I? Remember we said if we have 75 hundredths, that 0.75, that decimal in front of the 75, we're going to shift it to the right. Two places. And that's going to give us 75%. Now, I mentioned another option we could do. We could use it as a proportion. We could say 3/4, which we have, equaling to, how about it, n over 100. Now, you know what's going on here. We draw a little line here because we're going to separate and do 3/8 the same way here in just a second. What happens? Cross multiply. Absolutely. Everybody remembers. Oh yeah, I remember that. So we're going to take 3/4, n over 100. We're going to do a little cross multiply. We're going to take the 3 times 100. We're going to take the 4 times your n. Remember, cross multiply means you do on the diagonals here. So yes, we can go proportionally. And we'll mention something about it here in just a minute. I was about to jump the gun. I love to do that, don't I? Take your 3 times 100. I think most of you can do that in your head. I'm going to write it down there so you know where it came from. These two numbers, we call those the extremes of our proportion. They're our means, 4 and n. Now, multiply. How about it? We get 300. And if we divide 4 into 300, I'll go ahead and tell you what you're going to get. We can run on the calculator. Some of you probably have already done that. You get 75. This time, however, we don't need to move any decimals. We have our percent attached to it. So everybody good? Follow what's going on? Because remember, percent as a fraction is written over 100. So that's why we didn't have a decimal coming out here, all right? Came out 75 over 100, which is the same thing as saying what? 0.75, which we love to call that, but remember that means 75 hundredths. So there's your relationship. There's your relationship. Remember, 75% actually means 75 hundredths as a decimal. Don't confuse them, all right? Don't try to mix and put a 75 hundredths of a percent. That's a whole different animal. That is not 3/4, all right? The way we've got it is good, all right? Everybody good out there? Let's check out 3/8. Now we've refreshed everybody's memory, hopefully very well. Let's pick it up. 3/8 time here, all right? There we go. There's 3/8. Now, where are we going to go with that? We're going to do the same story. We are going to take and put 8 on the outside because, again, it's division. So we're going to divide 8 into 3. This time it may take a little bit more to get to the end of this tunnel, but we will. It's a terminating decimal, which means it has an ending. In case you're wondering, what is that word, that terminating? Wow, sounds like Arnold Schwarzenegger, right? And it's what it does. He ends things, all right? And then the Terminator series. There, I digress. Some of you are going like, I think I remember when that was out. Okay, now let's go and divide 8 into 30. And this time it only goes 3 times. Over here we had a different setup, so we're only going to get 3 out of this. And I'm already putting the decimal up here so we don't forget, because that's what happens. We go straight up in the end. There's nothing shifting at this point, so we know where that decimal is going to pop up. But we're going to work this thing until it ends up. Now, let's do a little multiplication. That's what the Lex is there for. And I get 24. Subtract 24 from 30. Of course, we're going to get 6. Everybody remember that little borrow routine business? All right. Keep going with that. Let's see. 8 doesn't go into 6. That's good news. That means we need to bring down the 0. So let's pop it in there. There comes 0. Move it straight down. And we get a 60. Oh, 8 goes into 60 about 7 times. And I say about 7 times because it doesn't make it 60 exactly, but it's pretty close. We get 56 when we multiply there. So subtract out one more time. Whew, 4. Bring another 0 all the way down. We're into 40. Good news, it goes in there 5 times, and we are going to be accomplished. Done, if you will. So again, here we go. There's 40. We have nothing left over. That's nice. Terminating means you have a remainder eventually of 0, all right, when a fraction terminates into a decimal, okay? A terminating decimal, we call it, because it has an ending, thank goodness. Now, but we want percent. So bring it over here. Let's see what that does. That is going to give us, remember, move that decimal 2 places, and that's where I like for you to be careful with it here. That's going to give us 37.5%. 37 5/10, 37.5 as we like to call it. All those good things. That is your percent. Will it work if we do a fraction? Certainly it will. All right, so let's take a look at that real quick. We do the 3/8 equaling to n over 100. I've got 8n equaling 300. Do you all see the difference? After you've seen a couple of these, what's the difference here when we've got this? This is just going to, this takes care of that, those 2 zeros take care of basically what we did here, all right, when we added zeros and had to figure out what to do eventually through the decimal. So it's just still going to be the same division. It's just going to come out without a decimal this time, all right? So our n is going to equal 37.5%. And that's where we come up the difference, all right? It's same answer, same solution, just 2 ways to derive it, 2 ways to find that changing from the fraction to the percent. You pick which one you like best. I think they're both equally efficient and equally good ways to go, all right? So there you have it, a little short look and a refresher, all right, on how to change from a fraction to a percent. Now, let's play this game out here. Let's look at 7/9 and 7/11. A little bit different moment here, and let's see why. First of all, I'm going to start with 7/9 over here. Ha ha. Over here, we're going to have 7/11. Life is good, except we got to change to a percent. All right? That's not so bad. That's not so bad. So let's see what happens here. First of all, we got 9 on the outside. Remember, we're saying 9 divided into 7, or 7 divided by 9. All right? But the 7's on the inside, and we're going to pull this decimal with a 0, and we're going to say, oh, that one's easy. Put the decimal straight up, right? Because we're not going to need to move anything here. We have 7 times 9, which is 63. We subtract and we get 7 again. Well, we bring a 0 down here, and look what happens. We get the same thing. We're dividing 9 into 70. So it looks like we're going to get a 7, and you know what happens when we do that. And again, here we go. Same old story. It just starts repeating itself. This is a repeating decimal, not terminating. It never finishes, all right? So what we're going to do, we're going to change this to 77, but not just leave it 77%. We're going to put a decimal, we're going to put a 7, and we're going to put a bar over it. Because that tells me that little 7 is going to keep repeating, repeating, repeating. How about that? And you say, well, wow, Ernie, that's kind of a touchy little situation there. It could be, but you know what? If you were to hit your calculator, you want to do it, everybody want to hit the calculator? Let's hit the calculator real quick. If we were to take 7 and we were to divide that by 9, you say, Ernie, you wouldn't lie to us, would you? No, I wouldn't. There's a 777s. Now look something there. There's an 8 that popped up. Some of you say, you didn't mark an 8 in there. That just simply meant they rounded off. It's going on and on forever more, folks. So they stopped that at goodness. Let's see, 4. Whew, a lot of decimal places. All right, if we were to count back up there, 2, 4, 6, 8, 10 places. So that 10th place, that's why there's an 8 there. It should still be a repeating 7, but you get the idea. All right, so calculators have to round off, just like we tend to round off. But that's a nice, if you look back at my paper here, the notation is really nice that we've got the 7 with the bar over it. So now let's check out 7/11ths. And I'm going to play this out just a quick run here. Again, add that decimal, add the 0. You say, well, gee, Ernie, what's it going to do? And that's a really good question. How many times will 11 go into 7? You think I know? Probably do, right? Let's go for 6. You say, well, why don't you do 6? Because, let's see, put a 6 there. Because 6 times 11 gives us 66. Those are things we can do kind of in our head. And we bring down a 4. Oh, goodness. And we have a 0 that's coming down. And look what's going to happen here. We're going to say that goes in there, how about it, 3 times? Does that sound good? 3 times? What we want? I think so. 3 times 11 is 33. And we subtract, oh my goodness, we're back to 7 again. Well, you get the idea. If we bring out another 0, we're going to have the same game story. We're going to have the same game plan here because we're right back where we started. Again, another repeating decimal. This time, we've got the bar hanging out there over 2 digits, all right? Because it's not just the 6, it's going to be the 3 that joins in the game. Now you say, well, how do we figure that out? How do we do it about that? It's a percent, same story. We're going to move that decimal 2 places, 63, and we're going to put that 63 with the repeating bar over it. We got it fitting in just perfectly. Right, there you go. And once again, you could use that business with the n over 100. You could set up the proportion. It's going to come out the same way. You're going to get this value for your decimal on the first one. You're going to get this one for the second one. Quick look at the calculator. It will round off, I guarantee you. You got the idea, right? So let's take a look at it. Let's clear out what we had there. Say goodbye 7/9. And let's do 7 divided by 11. And let's see where it takes us. It takes it exactly where I said it would. 63, repeating, repeating, repeating. Then all of a sudden we got 64 because you see the 6 forced the 3 to round up to 4. It had to finish it somewhere, but just ignore that. The fact is it is actually a repeating decimal forevermore. It does not quit at the end. So that's just a rounding off to the nearest 10 decimal places. You get the idea. So again, folks, careful with those repeating decimals versus terminating decimals. But hey, you can handle them. You've got a way to get out of it. All right, so there you have it. Now, where are we going to go from there, you may ask? Let's talk about a relationship between, we had it a minute ago, 75%. Let's see what we're going to do here. Got a story of Miss Jewel here, out to plant some seeds, all right? She expects 75% of the seeds that she plants are going to work out and develop. You know, that happens a lot. Not every seed germinates, all right? So basically, what we're thinking about here is we want to get 45 plants. So she wants 45 plants. They're going to be growing, producing, whatever they need to do. How many seeds would she need if she only expects 45 out of that amount to germinate? And that would be a 75% amount. So there's a couple of ways we can look at that. How about it? Let's start the difficult way, all right? There's nothing difficult about this. We're going back to the percent formula. All right, we saw about this being fractions of percent today, so we're going to make 2 fractions, which kind of make a proportion. According to this, we said 75 over 100, la-di-da, all right? 45 plants we want in the end. How many do we need to start with? See, that's what's going on. We're looking for that total. So we're going to call it in. We know the part that we want to happen is 75% of it, and that comes out to be she would like 45 plants. Bet she's going to have a real nice set of maybe 5x9 garden rows, those kind of things, okay? So she wants 45 of them to germinate. Actually, if she plants them all, they're just going to be randomly scattered, right, with maybe a bigger amount. We got to find out how many the amount is and see how she would maybe plant them and hope they all would germinate, but she's only expecting 45 to make it. So let's see, or she could do this. She could pot them all and let them grow, and then, okay, we'll take the 45 that make it, right? So you get the idea, different applications here, different ways she can think this through that may save her a lot of time. Now, I'm looking at 45 out of something to give me 75 over 100. Those are rather complex numbers, you know, but look at what happens. We can change 75 hundredths to what? Think about it. Cents, dollars. Yes, it's 3/4, right? So let's do that. Let's make this happen to be 45 over n equals 3/4. A lot easier situation. I can multiply almost maybe in my head. I mean, don't get too cocky, right, Ernie? When you do that, you're always in a trouble spot. Looks to me like that 45 times 4 is going to actually give us, got it? Well, 2 of them makes 90. Double that, you get what? 180? Absolutely. So we've got 180 when we multiply. We've got 3n going one direction. Oh, mental math is a wonderful thing, my friends. If you didn't catch where I got 45 times 4, again, double. That'd be 2 times 45. That would give you 90. And then 2 more, double it again, all right? Because that's 2 times 2 gives you 4, right? You got me. So speaking of which, let's go ahead and finish the division because that's what you came for, right? I get 60. So she needs 60 seeds to begin with. Remember, these are coming back to our seeds. Much easier than trying to figure out, okay, let's divide 75 into 4,500. We have calculators, sure. Get your cell phone, do it, all right? You'll get 60. Believe me? Let's believe me, all right? Let's check it real quick. Let me clear this one off. Let's go back real quick here. We're multiplying. We get 4,500 if we did the cross multiply gig, and we divide by 75. Will we get 60? Y'all know we're going to get 60, right? There we go. So got the telephone, got the calculator out there while you're gardening or getting a plan or trying to figure it out? Go for it. That'll work. But coming back to my paper here, we've got 3/4. So much easier. So if you can reduce a percentage that you're thinking about into a fraction and then do the cross multiply, you can do a lot of that mental math in your head. And that's a lot easier, isn't it? We always like easier. I do. So let's see what else we've got coming our way, all right? Let's see happening behind here. More percents, more dealing here. It says, what is the percent of increase if a stock increases from $40 to $48? All right, let's see what we're talking about here. Percent of increase. So again, we're going to go for a fractional part of percent here, all right? Question is, what is our n over 100? Now, I'm looking at 2 numbers here. And it's easy to say, oh, do we just put 40 over 48? We could do that. Then have to do a little more jimmying with the result. We'll talk about that in just a second. But what we could do here that I think would be even easier, you know how I think is easier, is to go ahead and subtract, find out what the actual increase is here. So take 48 minus 40, do that in your head, right? $8. That is the increase. Now, here comes a big question. Where did this thing start? Where did this thing start? Was it at 40 or 48? Which number are we putting in down here under the 8? Makes a big difference, absolutely. So let's go with, I think 40 looks good. Now, remember what I said a little bit. Let's relate some fractions here. All right, let's go with some fraction thoughts here. You know, this will reduce. This 8 over 40 will reduce to how much? What? 1/5? 1/5. Isn't that grand? Equaling n over 100. There's a nice relationship right there. And you say, well, Ernie, what if you can't reduce that 8 over 40? Well, 8 over 40 obviously would, but let's say you had 2 numbers that wouldn't reduce. You still cross multiply and do the best you can with your calculator. You may have a repeating decimal, and you would change it to a percent. Maybe you go to the nearest tenth, nearest hundredth as your teacher or your problem that you're working from the textbook or your online sheets or whatever you're looking at. You know, round off to whatever it asks you to round off to. In this case, oh my goodness, is this not easy mental math? Everybody nod your head. Yes, it is. Cross multiply. We got 5n equaling to 100. Divide 5 into 100. We can all do that. N equals 20. And remember that, my friends, is the percent that we're looking for. So we increased 20%. Now, what if you had gone and done what sometimes we see those two numbers and we don't necessarily read it completely, then we come out and read, oh my goodness, we could have done better. Well, let's suppose we had put, what do we say here? 48 over 40 maybe? You say, Ernie, can you do that? Sure we can. In other words, we ended up at 48, we started at 40. And we're going to see what goes on with that. Now keep in mind, we're going to have to do some fixing here, all right? But let's play the same game I did just a minute ago. Let's see if we can get that thing to reduce. Can we? Everybody thinking with me? I think we can. We can divide 4. Can we do better than 4? We can divide 8. Oh my goodness, we can take 8 into both of those. GCF time here. So let's just reduce that thing down to 6 over 5 equaling n over 100. And I hope everybody's noticing, Ernie, that's more than 100%. It's 6 over 5. Yes. So obviously we didn't increase over 100%, but what that is telling us is actually 100% plus the actual increase. You see? See where it's going? So yes, we can get out of this jam that Ernie Roberts is not going to take you down a path you can't get out of, right? So we've got 5n, cross multiply time again, all right? And this time we're going to get 600. We can all do that, right? 6 times 100. That was easy. Now, again, that's a mental math moment here. We can say 5 into 60 goes 12, and we have a 0 left, so we're at 120%. Now, that's what 48 out of 40 is, okay? It's 120%. If we had 100%, we had no increase. We stayed steady. So what is the actual increase here? It's going to be 120 minus that 100%. We'll put a little percent there. And that, once again, takes us back to 20. So yes, you could figure it out from there, all right? It would be quite possible to do if you forgot to do the little subtraction moment. But hopefully, in the end, you understand 120%, that makes no sense. Absolutely. You've got to get back to your 20, all right? So there's your addressing of the problem. And it still involves, hey, reducing a fraction, do a little mental math. Let's do one more here for the road. How about this last one here? This one may require a little help of our calculator. If it does, that's cool. That's all right. Okay, here we go. The percent of decrease if a price of a television drops from $500 to $425. Now, what I'm noticing, what hopefully all you guys are noticing is we're looking for that percent this time of decrease. We're looking for the drop, all right? So we know it's going to be, it's got to be less than 100%, right? Can't? Okay, we won't go there. But if you have 100%, you have nothing left, right? So you can't go to a negative drop, all right? So in other words, this one is going to be less than 100. Now, what happened? What did we decrease? Where did we go? Well, we started at 500, right? And we went to 425. Now, if you put 425 in there, that's how much price you retained, all right? You don't want to subtract that from 100%. That would get you where you're going. And I'm not sure we're going to have enough time to finish if I go both ways. And I don't think we will. But let's do this. Let's subtract that 425. That's going to be a 75, I believe. Everybody good on that? Nod with me. I like it. Hope it works well. We'll find out. Cross multiply. This one may not be so pretty. You know, we could reduce that fraction, but since we're running low on time, we're just going to go ahead and hit the calculator here in just a second. We're going to get 500 in. And we did drop 75 bucks, so we're going to go 7,500. Ah, I already sense something happening. You guys sense something happening on this? Let's see what actually happens. Will this come out even? I hope it does. Let's take 7,500 divided by 500. I just love to create mystery. I'd make you think maybe it's not going to come out even, maybe it will. Oh, let's find out. Ooh, it did come out even. Yay for us. 15%. Now, could we have reduced? We certainly could have. We could have not. Actually, 25 would divide out of there very nicely, all right? Could we have gotten it down to 15 over 100? If we divided both of these by 5, we certainly could, all right? So that's another way of looking at it. Does everybody see what I just said? You could divide both of those by 5, you get 15 over 100, which guess what? 15%. Another way you could look at it. Great moments here today. Percents of increase, percents of decrease, fractions relating to the decimals and to definitely the percents, all right? We always think of fractions to decimals, but fractions to percents are just as fun as the other, all right? And I hope you've enjoyed the show today. A little practicality there, hopefully. A little repeating, a little terminating, but you know what? Good show. We hope to see you again next time. We'll see you then.
Hello, I'm David Reynolds, President of Home Federal Bank. On behalf of East Tennessee PBS and Home Federal Bank, I am pleased to announce this year's Be More Award winners. Each month, Home Federal Bank and East Tennessee PBS present a Be More Award and recognize a leader or organization that provides important services and support to our community. Home Federal is proud of our